ML workflow. AI beginner level. Introduction. When building a machine learning system, it is not enough to just train a model. Machine learning involves a series of steps that help turn raw data into a useful prediction system. This process is called the ML workflow. An ML workflow gives a structured path for solving machine learning problems from start to finish. It helps developers understand the problem, collect and prepare data, train models, evaluate results, improve performance, deploy the final system. ML workflows are used in many real-world AI applications such as recommendation systems, fraud detection, medical diagnosis, sales forecasting, image recognition, spam detection. Understanding the ML workflow helps beginners see how machine learning projects are built in the real world. What is ML workflow? An ML workflow is the step-by-step process used to build, train, evaluate, and deploy a machine learning model. In simple words, ML workflow equals the full process of building a machine learning solution. Example concept. Problem means data means preparation means training means evaluation means deployment. The workflow helps organize machine learning tasks in the correct order. Step 1. Define the problem. The first step in an ML workflow is to clearly define the problem. Before building a model, we must know what we want to predict, what kind of data we need, whether the problem is classification, regression, clustering, or another ML task. Examples: predict house prices, detect spam emails, identify customer churn, recognize objects in images. Example concept. Clear problem definition means better ML solution. A well-defined problem makes the rest of the workflow much easier. Step 2. Collect data. Machine learning models learn from data. So after defining the problem, the next step is collecting relevant data. Data may come from databases, CSV files, APIs, sensors, websites, user activity logs. Example concept. Problem means collect useful data. The quality of the model depends heavily on the quality of the data. Step 3. Clean and prepare data. Raw data is often incomplete, messy, or inconsistent. Before training a model, data usually needs preprocessing. Common preprocessing tasks include removing duplicates, handling missing values, fixing formatting issues, converting text to numbers, scaling numerical values, encoding categorical variables. Example concept. Raw data means cleaning and preprocessing means usable dataset. This step is very important because poor data quality can reduce model accuracy. Step 4. Explore the data. Once the data is cleaned, the next step is to understand it better. This is called exploratory data analysis, EDA. In this step, developers look for patterns, distributions, relationships between features, outliers, class imbalance. Example concept. Prepared data means analysis means insights. Exploring the data helps choose the right model and features. Step 5. Split the data. To properly evaluate a model, the dataset is usually split into separate parts. Common splits include training data, validation data, testing data. Typical usage. Training set means used to train the model. Validation set means used to tune the model. Test set means used to measure final performance. Example concept. Dataset means train set plus validation set plus test set. This helps check whether the model performs well on unseen data. Step 6. Select features. Features are the input variables used by the machine learning model. Not all features are useful. Some features may be irrelevant, redundant, noisy. Feature selection helps keep the most important information. Example concept. Many features means choose important features means better model. Good feature selection can improve both speed and accuracy. Step 7. Choose a model. After preparing the data, the next step is selecting a machine learning algorithm. The choice depends on the problem type. Examples: linear regression for regression, logistic regression for classification, decision trees, random forest, k-nearest neighbors, support vector machines, neural networks. Example concept: problem type plus data means choose algorithm. Choosing the right model is important for good performance. Step 8. Train the model. Training means teaching the model using the training dataset. During training, the model learns patterns from the input data and target output. Example concept: training data means model learns patterns. The model tries to reduce errors and improve predictions during this phase. Step 9. Evaluate the model. After training, the model must be tested to see how well it performs. Common evaluation metrics depend on the problem type. For classification, accuracy, precision, recall, F1 score, confusion matrix, ROC AUC. For regression, mean absolute error, mean squared error, root mean squared error, R-squared score. Example concept: trained model means evaluation metrics means performance check. This step tells us whether the model is good enough. Step 10. Tune the model. Sometimes the first model is not the best. Model tuning improves performance by adjusting settings called hyperparameters. Examples: tree depth in decision trees, number of neighbors in KNN, learning rate in neural networks. Example concept: model evaluation means tuning means better performance. Tuning helps improve accuracy and reduce errors. Step 11. Test on unseen data. After training and tuning, the final model is tested on the test dataset. This gives a realistic estimate of how the model will perform in real life. Example concept: final model plus unseen test data means real performance. If performance is good on unseen data, the model is more reliable. Step 12. Deploy the model. Once the model performs well, it can be deployed into a real application. Deployment means making the model available for actual use. Examples: website recommendation engine, fraud detection system, mobile app prediction feature, customer support AI tool. Example concept: final model means deployed application. Deployment turns the trained model into a practical AI solution. Step 13. Monitor and improve. Machine learning does not end after deployment. Over time, data can change, user behavior can shift, and model performance can drop. So models should be monitored regularly. This may involve checking prediction quality, retraining with new data, fixing bias, updating features, improving performance. Example concept: deployed model means monitoring means retraining and improvement. This step keeps the ML system useful over time. Full ML workflow summary. A simple machine learning workflow looks like this. Define problem means collect data means clean data means explore data means split data. Means choose features means choose model means train means evaluate means tune means test means deploy means monitor. This is the complete life cycle of a basic ML project. Why ML workflow is important. ML workflows are important because they help developers follow a clear step-by-step process, avoid mistakes, build more accurate models, improve project organization, make machine learning systems reliable. Example concept: structured workflow means better machine learning results. Without a proper workflow, projects can become confusing and ineffective. Example Python libraries used in ML workflow. Different steps in the ML workflow use different Python libraries. Examples: import pandas as PD, Import NumPy as NP. From sklearn. Model _ selection import train _ test _ split. From sklearn. Linear _ model import logistic regression. From sklearn. Metrics import accuracy _ score. These tools help with data handling, preprocessing, model training, evaluation, real-world applications. ML workflows are used in many industries. Healthcare. Building models for disease prediction and diagnosis. Finance. Creating fraud detection and risk analysis systems. E-commerce. Powering recommendation engines and customer behavior prediction. Transportation. Improving route optimization and self-driving systems. Marketing. Predicting customer responses and sales trends. Concepts learned from ML workflow. Understanding ML workflow helps beginners learn. Checkmark how machine learning projects are built. Checkmark why data preparation is important. Checkmark how models are trained and tested. Checkmark why deployment and monitoring matter. Checkmark how real-world AI systems are developed. ML workflow is one of the most important foundations in machine learning. Simple definition. ML workflow. The step-by-step process of building a machine learning system. From problem definition and data collection to training, evaluation, deployment, and monitoring. Final summary. ML workflow is the complete process used to create a machine learning solution. It begins with defining the problem and collecting data, then moves through cleaning, feature selection, model training, evaluation, tuning, testing, deployment, and monitoring. Each step plays an important role in building an effective AI system. Understanding ML workflow helps beginners see the bigger picture of machine learning and how real-world AI projects are developed from start to finish.